Hello friends, good morning. I welcome you all to this session. So, in the last class, we were discussing about conditional probability and also its p-values. So, in today's class, we'll start with another topic that is pertaining to probability itself. So, we are going to talk about multiplication theorem on probability. What friends? We are going to talk about multiplication theorem on probability. So, as a part of IIT JAM and CAT classes, we are started with the first topic that is probability. Okay, so today we are going to discuss what? We are going to discuss about multiplication theorem on probability. What do you mean by multiplication theorem? How to solve the questions based on multiplication theorem on probability? All these things we are going to today discuss in today's session. So before that, I'd like to inform you again about our course, that is upcoming course, that is Secure BLO AR 100 Rank Assurance Program. Okay, it is for IIT JAM Biotechnology February 2025 exam. Okay, it is a well-designed 6 months plan. Okay, meticulously prepared by Dr. Chandra Shekhar. It will include what is the USP of this course. It is going to include interactive live and recorded sessions. Live sessions where you can attend live and ask doubts on the spot itself. And those who cannot afford to, who cannot afford to have the time to attend live, they can attend watch the recorded sessions. And those who are watching the live sessions, they can also watch recorded sessions for the purpose of revision. Okay. And the USP of Chandu biology classes is the well-crafted PPTs. It is well known for its PPTs and also expertly designed study material. Apart from this, just going through the classes, just studying the study material is not enough. You have to give the test to assess where you stand with respect to your preparation. So for that, we're having mock tests. Okay, it may be sectional mock test or full length mock test. So we are having 30 chapter wise and 10 full length mock tests. And individual attention will be given to every student. That is, complete handholding will be given to every student so that they achieve great success in the upcoming IIT JAM examination. And similar course we are starting for Secure Below AR 100 Rank Assurance Program. That is, this course is for CAT B and Common University Entrance Test for post-graduation 2025 examination. So this is a 8 months plan. So USP remains the same. Even for this course, we are providing live and recorded sessions and also well-crafted PPTs and expert design study material. Here also we are providing the test series. That is 13 chapter wise and 10 mock tests. Individual attention will be given to every student. So the previous course, that is for IIT JAM Biotechnology, that is going to start from 1st October. As you can see here, it is going to start from 1st October. And even this course for GAT B is also going to start from 1st October, friends. Okay, remember the date. It is fast approaching, that is 1st October. So I request all the aspiring aspirants to enroll for the course as soon as possible and get a very good head start with respect to your preparation. All right, friends. Having said this, I'm remembering again. Okay, I'm reminding you again that it is going to start from when? It is going to start from 1st October. All right, friends. So let us continue with our discussion on probability. So in the first class, we spoke about various terminologies associated with probability. Okay, be it what is a trial, outcome, sample space, partition of sample space. Okay, and what do you mean by event? What do you mean by mutually exclusive events, exhaustive events, all these things. In the second class, we learned about axiomatic approach to probability, where we learned about addition theorem. Then based on that, we solved a lot of PYQs based on axiomatic approach to probability. I told at least one question will come from this topic. Next, we learned about what? Next, we learned about conditional probability and its properties. Conditional probability and its properties. That is, suppose there are two events E and F. What is the probability of event E occurring? So, given that event F has already occurred, for that we learned on formula. So, conditional probability and its properties. Based on that, we solved the PYQs. There we used to what? We used even the addition theorem. So, questions are coming not just from conditional probability. It's coming as a combination of addition theorem and conditional probability. So we learned conditional probability also and axiomatic operational probability also. So next we are going to learn very important concept, highly important concept, that is multiplication theorem on probability. Okay, today we are going to discuss about multiplication theorem on probability. How these things are solved. So conditional probability is done. So today we have to do multiplication theorem on probability. We will study about properties of conditional probability. So today we are going to discuss multiplication theorem on probability. So when I told multiplication theorem on probability, so what do you mean by that? Suppose, so today's topics are multiplication theorem on probability, examples and POQs analysis. Examples we are going to deal it today itself. We are going to cover multiplication theorem on probability today. Examples we are going to cover today as much as possible. And POQs will be done in the next class, that is in the evening session. All right, friends. So when I told this question is already solved, let us see. These questions we have solved. So when it comes to multiplication theorem on probability, okay, what does it talks about? What is the significance of multiplication theorem on probability? So when we are talking about multiplication theorem, suppose there are two events which are occurring simultaneously. Two events occurring simultaneously. Simultaneously means what? See, two events, simultaneous occurrence of events. That is, two events occurring simultaneously means it's occurring at same time. Occurring at same time. Okay, occurring at same time. In the previous class, we solved one question. A toss and a coin and a dice is thrown, tossed simultaneously. Simultaneously means at the same time. At that time, multiplication theorem comes into picture. So the multiplication theorem on probability explains that the probability of the simultaneous occurrence of events. Suppose there are events, suppose two events or three events or four events. But actually we'll be studying up to three events, not four events. When we talk about initially two events, suppose two events are occurring simultaneously. For that, how to find the probability? That is told by what? Multiplication theorem on probability. Okay, friends, did you understand? Multiplication theorem on probability talks about simultaneous occurrence of events. What does it talk about simultaneous occurrence of events? It helps in finding out probability of simultaneous occurrence of events. What does it help? It helps in multiplication theorem. I'll write it empty. Helps in finding out probability of simultaneous occurrence of events. Simultaneous occurrence of events. So how to find this probability using multiplication theorem? So suppose let there be two events. Let E and F be any event or two events. If be any event, then the probability of multiplication theorem talks about what? Simultaneous occurrence. So the probability of simultaneous occurrence. The probability of simultaneous occurrence of E and F. E and F is given by what? Is given by, very important friends. Please focus. Is given by, let me use another color. Is given by probability of E intersection F. Because simultaneous means common events. That is, it's happening at the same time. That's why it is given by P probability of E intersection F. Okay, it is given by probability of E intersection F. Remember this, the probability of E intersection F. So how to find probability of E intersection F? First of all, you must know multiplication theorem deals about simultaneous occurrence of events. Multiplication theorem when we use to find the probability of simultaneous occurrence of events. Suppose, just now, since I'm talking about multiplication theorem, you will know that you will apply probability of what? You will apply multiplication theorem when we are finding probability of simultaneous occurrence of events. But in the examination, you won't say multiplication theorem. In the question, they will give simultaneous occurrence of events. That time you should know that. That time you should know that we have to apply multiplication theorem to solve these questions. In order to find the probability of simultaneous occurrence of events, I'm repeating again. In order to find the simultaneous occurrence of events, probability of simultaneous occurrence of event, you have to apply multiplication theorem. So by applying multiplication theorem, you can find the probability of simultaneous occurrence of events. So when it comes to multiplication theorem, to find the probability is given by probability of E intersection F, that is for simultaneous events E and F. P of E intersection F, that is probability of E intersection F. So how to find P of E intersection F? So by conditional probability, we know that probability of event E that has occurred, event E occurring, given that probability of event F has already occurred, is given by probability of E intersection F divided by probability of F. Okay, or this implies what I can write, then I can find probability of E intersection F. This value I can find out. So if I cross multiply, I get probability of E intersection F. Probability of E intersection F is given by what? Probability of E intersection F is given by probability of F into probability of E by F. Got it, friends? Or suppose that instead of E and F, suppose that probability of event E has occurred and probability of F has to occur. That is, if I write here probability of F over E, that is probability of event F occurring, given that E has already occurred, that time we can write it as probability of E intersection F or F intersection F is same, E intersection F divided by, I can write it as probability of E. Correct? No. So this will become, so this ultimately this will become what? This will become, or you can write it as probability of E intersection F can be written as what? Probability of E into probability of F by E. So this is the formula you have to remember for two events. Okay, this is the formula which you have to remember for how many events? For two events. You have to remember for two events. Got it, friends? This is the formula for how many events? For two events. Simultaneous occurrence of two events. So what do you do if there are three events? Okay, how to find the probability of simultaneous occurrence of three events? Now let us find out. Now you understood for two events. So probability of simultaneous occurrence. Listen carefully, each and every word is very important. Occurrence of three events, simultaneous occurrence of three events. Okay. So when it comes to three events, let E, F, and G be three events. Then probability of simultaneous occurrence, probability of simultaneous occurrence of these events. These events mean these three events. Occurrence of these three events is given by what? Is given by, use another color, is given by probability of E intersection F for two events. For three events, it is E intersection F, F intersection G. That is common between E, F, and G. Okay. So probability of E intersection F, F intersection G. Okay. Now, how to find this one? Probability of E intersection F or this one. Okay, let me show. So probability of E intersection F for two events we found out as probability of E into probability of F by E, or you can also write it as, given that event E is occurring and event F has occurred, for that you can give it as probability of F into probability of E by F. You can use either of these formulas, depending on which event has already occurred. But for three events, is for how many events? Is for two events. I'm writing the formula at one place. This is for three events. For three events, that is probability of E intersection F intersection G. Probability of what? Probability of E intersection F intersection G. Got it, friends? Just a minute. Probability of E intersection F intersection, not F, it is again G. So for that, what you have to write is, first of all, probability of event E has occurred. Okay. Suppose probability of event E has occurred, or let me take probability of event F being occurred. That the second event has occurred, first event has not yet occurred. Okay. So this is given by probability of F into probability of E by F. Okay. Now, after this and this, what has happened? Two events has already occurred, E and F. We have to find the probability of event G. So that is given by probability of G divided by probability of E intersection F. This is the formula, friends. Here, probability of first case, probability of event F has already occurred, probability of event E is already occurring. I mean, event F has already occurred, probability of event E is occurring. Event E is yet to occur, F has already occurred. So for that, we will use this one. This which we have used in conditional probability also. Now, after these two, even E and F has already occurred. Now, you have to find the probability of G. Probability of G with respect to E and F. That is, E and F has already occurred. That is, probability of G divided by E intersection F. So, this is the formula for three events, friends. So, this is the formula for three events. So, this you have to remember very carefully. This you have to remember very carefully. This you have to remember very carefully. Okay. Or for this also, you can write another formula. See, instead of F being occurred, suppose event E has occurred. Or you can write event E has occurred. Here event F has occurred. Here F has occurred. F has occurred. Here F has occurred. F has occurred. Here event E has occurred. E has already occurred. I'm writing for your reference. Now here you can also write it as probability of E, where E and event E has occurred already. Then you are finding probability of F with respect to E. So this will become probability of F with respect to E. But this third term remains the same. Probability of G with respect to E intersection. So this is the formula, friends. So this is the formula which you have to remember. This is for two events. Okay, this is for two events. This is for three events. Okay. So one more note you have to remember. So why we are using multiplication theorem? Multiplication theorem we are using to find the probability of simultaneous occurrence of events. So we learned the formula for two events, which you have to remember, and we also learned the formula for three events. Got it, friends? We also learned the formula for three events. So based on that, we will solve some questions. But before going to that, you have to remember one note. Okay. To remember one note. First thing is E intersection F. E intersection F can also be written as just EF. Okay. Similarly, E intersection F intersection G can also be written as EFG. Why I am telling this? Because in certain questions, they won't give you E intersection F. They will just give you as EF. They will not give you E intersection F intersection G. They'll just give you EFG. They'll ask you to find probability of EFG. Probability of EFG means E intersection F intersection G. This you have to remember. Okay. E intersection F is nothing but equal to EF. Probability of E intersection F intersection G is probability of EFG. Probability of EFG is not equal to probability of E, probability of F, and probability of G. It's not like that. Probability of E intersection F, F intersection G is equal to EFG means, suppose they ask you to find probability of EFG means you have to find the probability of E intersection F intersection G. Okay, got it, friends? This note you have to remember. So, based on this multiplication theorem, we will solve some questions, some example questions, so that it becomes easy for you. Here, what is the probability that both balls, drawn balls are red? Okay, the question is incomplete. Drawn balls are red. Okay. Now, example one, an urn contains. Urn means you can take it as a box or anything, or a bag or anything. An urn contains 20 red, 20 red and 10 white balls. Two balls are drawn from the urn, one after the another. Okay, one after the another. That is continuously they are removing one after the another without replacement. Suppose you remove one, and to remove another one, you are not going to put back the first one. You are not going to put back the first one. So that means what? If you are putting back the first one again, that means with replacement. Okay, with replacement means you are putting it back. Without replacement means you are continuously just removing. You are not adding it back to the urn. You are not adding it back to the bag. Okay, so without replacement means you are not putting it back. So what is the probability that the both drawn balls are red? So this is the question. So first of all, let us draw the urn. Okay, let us draw the urn. Okay, that is with the urn. Okay, here we are having how many balls? Here we are having 20 red balls. 20 red. Okay, plus 10 white balls. So total we are having how many balls? Total we are having 30 balls. 30. Now you must remember one thing. Now from this urn, if I remove one ball, okay, let there be red ball. This urn, if I remove one ball if I remove, okay, this will become turn into what? This will turn into this urn will become. Let me draw the urn again. Listen to me carefully. So if I remove one red minus one red, so this will become how much red? This will become 19 red plus 10 white balls. So this will become total is how much? 10 plus 19, 29. So this will become 29 balls, one red. Okay, so this is first case. So here probability of removing first one red ball that we have to find out. So that is probability of R1. Removing R, that is while you remove red ball for the first time, that is R1. Probability of R1, that is removing red ball. Removing red ball is out of 20 balls, you are removing how many red balls? You are removing one red ball. Okay, one red ball. That means out of 20, it can be anything. So 20 out of 20 balls, you can be remove anything. So 20 out of how many? Total is there are 20 red balls. You are removing one red ball. So that is 20 out of 30. Probability of R1 is 20 out of 30. Okay, this is probability of R1 because you are removing one red ball. Out of 20 red balls, it can be any. So that's why you have to write 20 out of total. Okay, 20 out of total is 20 out of total. 20 out of total is probability of R1. Probability of R1 is what, friends? You are removing one red ball. One red ball can be any out of the 20. One red ball can be any out of the 20. So you can write it as probability of R1 is 20 out of 30. So now similarly, you have to remove another red ball. That is, let this be R2. Given that R1 is already removed. One red ball is already removed. Okay, friends. One red ball is already removed. So here how many red balls are there? 19. Okay. So total is how much out of total? This is what, friends? Total balls. Total balls is how many? 30. The total balls is 29. Because why? One red ball is already removed. So here it will be 19 red balls. So 19 red balls means 19 plus 10. White balls remains the same. 19 plus 1 is 29. So this will become 19 by 29. So probability, this is probability of R1, that is first red ball. This is probability of second red ball, given that first red ball is already removed. So this is, they are using conditional probability. That is probability of R2 divided by R1 is 19 by 29. So what is the probability that both the drawn balls are red? What is the probability that both the drawn balls are red? Means there two balls are drawn from the one after the another. So here we have to use multiplication theorem. Both the drawn balls are red means that is R1 and R2. That is we have to find probability of R1 and R2. Both the drawn balls are red means both are common. Common means what is common here? Both are red. Okay, both are red. So common, for whenever it is common, we have to use intersection. Probability of R1 intersection R2. So probability of R1 intersection R2, we have to find out. What is that? We have to find out. Now we have got this formula. See here, probability of R2, probability of R2 by R1. Correct? No. But instead of that, we know that by multiplication theorem, for two events, by multiplication theorem, multiplication empty means multiplication theorem for two events, we know that probability of E1 intersection E2 can be written as probability of E1 into probability of E2 by E1. So similarly, this can be written as probability of R1 intersection R2 can be written as probability of R1 into probability of R2 by R1. So that is equal to what? That is equal to probability of R1 is 20 by 30 into probability of R2 by R1 is 19 by 29. So if you solve this, 0 cancels, 0 cancels. So 19 2s are 38, 29 3s are 87. So this is the answer. So just you have to find here the probability that they are asking is probability of R1 intersection R2. That is both the all balls are red means you have to find common. That is common is both are red. That is R1 intersection R2 that you are getting as 38 by 27. This you are solving using multiplication theorem. That's it. Just both the balls are red, both the balls are black without replacement and all. You have to remember this. This is a very important step. Which step? This step. This step is very, very important. Why? Because here you are removing one ball and you are not replacing it by another ball. That's why this 20 red balls becomes 19 red balls and these 10 white balls will become 10 itself. But total will change. Total was 30 earlier. Since one ball is removed, it will become what? It will become 29 balls. That's all, friends. I hope you understood this example. Let us go to another example so that you understand. Look at this, friends. They are saying what? 3 cards are drawn successfully. That is one after the other without replacement from a pack of 52 cards, 52 shuffled cards. We know that in a pack of cards there are 52 cards. There are 52 cards. Okay. In a pack of 52 cards, what is the probability that the first 2 cards are king? What is the probability that the first 2 cards are king and the third card drawn is an ace? Third card drawn is an ace. Ace means what? The letter A. The cards having letter A. That is ace. Okay, like I told you, we have 4 types of card. Heart, diamond, okay, spade, club. Each of them starts with A, 1, 2, 3, 4, A, 1, 2, 3, 4, A, 1, 2, 3, 4, A, 1, 2, 3, 4. These things, this A, this itself is ace. Okay, so first let us talk about event 1. Event 1 is talking about that the first card is king. Okay, first card is king. Okay, event 2 is talking about second card is king. The first card is king means then second card is king. Okay. Then event 3 is talking about getting a king. Okay. First card is king or getting a king. One and the same. Second card is king. First 2 cards are king. That is first card is king. And this is third card is yours. Event 3 is talking about third card is ace. Okay. First card is king means the probability of even is nothing but what? Probability of even. There are total how many kings? Heart, diamond, spade, club. They will have king. One king each, one king each, one king each. So it is 4 kings will be there. 4 out of 52. Now, out of this, 1 king is already removed. Now this becomes what? This total will become 51. Okay. Now this total will become 51. Now, you have to find probability of E2 when even has already occurred. That is what? Probability of E2 when even has already occurred. That means 1 king is already removed. What is the probability of event E2? That is probability of E2 with respect to even. Even that even has already occurred. See, this event even has already occurred. Then what is the probability of E2? Probability of E2 given that even has already occurred. So this is similar to previous question. That is, we found out probability of R2 given that R1 has already occurred, the previous question. So similarly, this will become probability of E2 given that E1 has already occurred. So here we are having 51 cards. Here already one king is gone. Okay, one king is removed. Out of 4 kings, one king is removed here. So here we are having 3 kings. So it will be 3 out of 51. Now, again, this will become how much? This will become 3 out of 51. That means next is here 3 kings will be there out of 51. Now, here one king is removed. Again, one king is removed. So this will become what? Out of 3 kings, one king is removed. So here there are 2 kings and the number of cards. So therefore what? Out of 52, one king is removed. Out of 51, one king is removed. Here we are having 50 cards. Here we are having 50 cards. Now we have to find probability of what? Probability of E3. Probability of E3 given that E2 and E1 has already occurred. That is E2 intersection E1 is what? E2 intersection E1 is given by what? Probability of E3 given that E2 intersection E1, given the E2 intersection E1. That is finding the probability of event 3 given that E2 and E1 has already occurred. So that is given by what, friends? That is given by how many spades are there? Sorry, how many aces are there? How many aces are there? There are 4 aces. There are 4 aces. Here also 4 aces. Here also 4 aces. Here also 4 aces. We are not touching the aces here. Aces 4 aces. Here also 4 aces because we are removing only the kings. Here also still 4 aces are there. But here it is probability of E3. E3 is what? Getting an ace. That is third card is an ace. Given that E2 and E1 are already occurred, it is given by 4 by 50. It is given by 4 by 50. Now, what is the probability that first 2 cards are king and the third card is an ace? That is meaning they are telling E1 intersection E2 intersection E3. That is all the 3 are occurring. Okay, all the 3 are occurring. Event 1, event 2, E3 are occurring simultaneously when the 3 cards are taken out. Okay. So for that, by multiplication theorem, we know that we have to find the answer for this. We have to find the probability of E1 intersection E2 intersection E3. So this is given by what? Probability of E1 into probability of E2 given that E1 has already occurred into probability of E3 given that E1 and E2 has already occurred. Or I can write E1 and E2 because E1 E2 because we know that it is what? I told you E intersection F can be written as EF. Let us put the values. P of E1 is 4 by 52. Okay. This is 3 by 51 into this is 4 by 50. Okay. See wherever you can cancel. So this is 4 ones are. Okay. 4 ones are 4 13s. This is what? This is 2 2s are 2 25s. 2 25s are. Okay. 2 25s are. So this if you multiply, what you get? So this if you multiply, what you get? Please tell me the answer. This if you multiply, what is the answer you get? Please tell me the answer. What is the answer you get? Answer the answer you get. Please do the calculation. What is the answer you get on doing the calculation for this? Fast, you have to do the calculation fast. So, anyways, you can do the calculation by yourself. So ultimately you got it as this will be equal to this value is nothing but 4 by 52 into 3 by 51 into 4 by 50 into 4 by what is that, friend? Into 4 by 50. That is into 4 by 50. That is for E1 intersection E2 intersection E3. This is the answer for this question. You have to simplify this based on the options. You can, the options is given based on the options, you can simplify accordingly. All right, friends, I'll wind up here. Let us meet in the next session where we'll be talking about problems. That is PYQs based on whatever we discussed today. That is discussed now. We discussed only about what? The basics of multiplication theorem and probability, and also some examples based on that. In the next class, we will do the previous year questions that has been asked in IIT JAM biotechnology. Okay, examination. Previous year questions based on multiplication theorem that we are going to discuss in the evening session. All right, friends, I'll wind up now. Okay, have a nice day. Let's meet in the evening session, friends. Thank you so much for attending the session.